These ASICs are highly customized. They're in 5 nanometers going to 3 nanometers. And they're literally hundreds of thousands to 1,000,000 times faster for that particular Bitcoin algorithm.
Did create quite a stir, quite a buzz, and a lot of speculation, although they did hint at post-smartphone AI interface, whatever that means.
These breakthroughs don't mean that we are so much closer to an actual quantum computer. The progress is real, but so is the hype.
AWS seems to be having a bit more of an architectural problem absorbing these water-cooled systems right now. They've only just finally launched a air-cooled Blackwell-based node.
Welcome to the Orion X Download Podcast. Join Shaheen Khan, the Orion X analysts, and special guests as they discuss and simplify the big ideas in technology that are changing the world. Thank you for being with us.
Hi, everybody. Welcome back to another episode of the Orion X Download Analyst Roundtable, or ART, where we talk about a lot of different topics in technology. Full house today with Chris Krull, Steve Perno, Adrian Cockcroft. Adrian, you're at a very fun place this time. Tell us where you are.
Yeah, I'm in Budapest right now for the Craft Conference. It's a software craftsmanship event. I've been here a couple of times before. Beautiful city, got beautiful views out of my hotel window. I can recommend the Hilton here as a lovely place to stay. And I'm giving a talk tomorrow afternoon on platform architecture, platform engineering. And there's been some good talks so far. I went this morning to the opening keynote. It's a 2-day event. Just very briefly, Kent Beck, who's a well-known software technologist, gave a talk this morning that was quite interesting, talking about companies being either oriented around a forest or a desert as an analogy of the way they operate. And the forest is very supportive and community-based. It's where we kind of like to be. And from my history, like working at Netflix, the Netflix culture deck, that's very much in that space. And the other places are very much sort of Taylorism. You have to beat people to get them to work. Everyone's going to be bad, so you have to kind of like control them. So it's very much more of a control, blame-based culture, right? And sometimes you get little pockets of forest in the desert that the desert stamps out, right, or whatever. So he was basically trying to explain that if you had to recognize which one you're in, and people are asking, well, how can I convert my desert to a forest? And so you can't really. Well, the best thing to just leave and join a better company. That's my take on it anyway. It's just too hard, but it's one of those things. And the other thing I'd note was that when a company's growing, everything's a forest. You've got abundance, right? If you stop growing, then suddenly you're in a desert mode. And we saw that at Sun. When Sun stopped growing, it became very hard to get anything done. And I think we saw that recently at AWS. When it stopped growing, it got very locked down, very hard to get things done, and it's become more political, and it's not as much fun there as it was, I think, when I joined it in 2016 when it was high growth. So that's an interesting sort of way of viewing the world.
Right. I guess the counter argument is the people who are just in their natural habitat in one or the other. They might just
there are definitely some people that make it a desert around them or make it a forest around them. It requires actively.
Yeah.
Did you read Mary Parker Follett or did you read Taylor and decide that was your way of doing things?
That's why you're that's right. So you can let people know this company is becoming a desert. It's time for you to go join them.
Probably. Yeah. And I think actually, if we wanted to segue right in, like the latest place that's really a forest with way too much resources, Nvidia. They just come out with their numbers, growing more than expected, doing super well. So that's kind of my pick right now for like, it's great to be in a place that's growing fast and big, right? Lots of money to try new things.
No, they've been hitting on all cylinders and executing really, really well. And they've been doing it for decades. So it's really quite awesome. Their year-over-year compares are going to start looking not as great because they had a massive jump just about 4 or 5 quarters ago compared to the previous year again.
And then the other one that's sort of running on the coattails of that is CoreWeave, which is acting as sort of like a delivery buffer for all of the big water-cooled racks that Nvidia is producing. They'd rather not sell you a chip. They want to sell you a water-cooled rack full of chips. The NVL72 is sort of their preferred unit of delivery. And what CoreWeave's doing is building data centers that can take those. And then what CoreWeave has now got deals with both Google and Microsoft to supply capacity to them. And probably a longer discussion for another month, but AWS seems to be having a bit more of an architectural problem absorbing these water-cooled systems right now. They've only just finally launched a air-cooled Blackwell-based node with 8 Blackwells and an Intel-based unit, which is just like the basically upgrade of the H200-based system they had before, just in that same form factor of a air-cooled 8-node system. They know how to do those. They don't really have anything on their price list that you can get, which is based on these NVL72 clustered 72 GPU racks. It'd be interesting to see how long it takes for AWS to absorb this new GPU-centric architecture.
Well, I think the revelation in our pre-talk to me was that the introduction of GPU into the workloads and the AI workloads really do use a different architecture. And that different architecture has a ripple effect through facilities and power, not just power and cooling, but everything else, the control plane, management plane, all of that.
All the networking.
So it really is an architectural shift, not just a configuration shift. Now, speaking of NVIDIA, that's AI. So we had an event that we attended that we will get to in a second, but also the big news was OpenAI buying Johnny Ive's IO company for $6.4 billion, was it? Chris, you had some ideas on where our next device is going to come from?
Oh, it did create quite a stir and quite a buzz and a lot of speculation, although they did hint at post-smartphone AI interface, whatever that means. Collectively, we're sort of, okay, let's just place a bookmark here and check in when they actually talk about real deliverables. We've noted that there have been some attempts at people coming up with devices that have quite frankly failed in the marketplace. Kind of question, why wouldn't we just use the phone itself? And, it does make you step back and think, what does it take for a device without a screen to go mainstream these days anyway? So,
well, they didn't say what they're going to build, and previous attempts at doing so have not worked. We talked about Humane AI pin that came and went and wasn't quite working. And of course, Johnny Ive's reputation was eliminating features from phones. So who knows? We had the Java ring that started it all years ago at Sun.
still have, yeah.
So we'll see what they do, but they spoke of it so confidently. And with their reputations, you feel like you have to take them seriously. But man, is it hard to compete with a phone. It's really hard to compete with a phone.
Yeah. At least the way we think about it today, right? So
yeah. Right. So Adrian, you had the MeGPT project that you started some time ago, and that has also dominoed into other activities. You were on stage a couple of weeks ago at Soopra.ai's event. Let's talk about that.
Yeah. So towards the end of the talk I'm giving tomorrow, I actually go through a whole lot of slides I wrote in 2016 about work I did in 2010. And at the end of that, I say you can replace me by a short shell script, remember that old replace me by a short shell script that says we did that at Netflix 15 years ago. And you just repeat that. But if you want a slightly better answer, you can talk to my persona on Soopra.ai, where you can ask it questions. One of the questions I like as an example is, well, how would you introduce chaos engineering to a company? And it gives you a nice 10-point plan that makes sense. It's better than I would write if I had to answer that question in an email. I wouldn't give quite as much detail probably. So it's been trained with lots of blog posts and things like that. I'm trying to get more content types into this. So I've been tinkering around with it. And then, so the Soopra event, what they came up with was right now that's just you and the persona, and you ask it questions, you have a chat session. What they've announced Soopra 2.0, and they were demoing at the event, was the ability to have a group of agents communicating with a group of people. So it's a bit more social, and so you've got an agent for your persona that can chime in. So they put out a question and a few different personas popped up with different answers for whatever that question was. So that's sort of the idea, to make it a bit more collaborative. And then I was on stage answering some questions. And of course, I got the questions in advance and I typed them into Soopra and got my persona answers for them that I could read off of if I couldn't think of what I said myself. And I put out a blog post on that. It got, overall, between the two of us, I think we had better answers than either of us did alone. Right, my persona plus what I actually said live. So it's quite interesting overall.
Yeah, that was very clever.
And then most recently, I've started trying to figure out if there's a way to use MCP is the latest buzzword in AI software, and I've been trying to understand what it is and see if I can hook it up for this and figure it out. But right now, I'm still blundering about. So maybe next month we can talk about how far I've got in trying to code some MCP-related things.
Excellent.
I just wanted to take a half step back. I'm not sure if we've talked about Soopra on this podcast before, but first let's talk about the spelling, Soopra, in case people want to find it. But their focus is AI persona with domain expertise, such as energy efficient data centers, so you go ask Adrian a bunch of questions. And I think that building out a trustworthy, focused subject matter expert that can be accessible 24/7, take care of the kind of questions that you want to answer, but don't want to take the time to, or don't have the time to, I think is a great use case for.
Yeah, absolutely. So Adrian came across Soopra a few months ago as part of his own MeGPT project. He has since become an advisor, and the rest of us have got a little bit more involved as we feel there is a use case for what we do. So it's been quite interesting, and they're doing a great job. So go check them out. Let's go to digital money, cryptocurrencies, BTC, Bitcoin, and a lot is going on in that world. And Steve, you've been tracking it forever. I don't know where you want to start, but maybe the strategic reserve is a place to start.
Yeah, let's start with the strategic reserve, maybe end up with where we're going to be with the next CryptoSuper mining report,
Bingo.
which is fairly imminent. So the strategic Bitcoin reserve was something that Trump campaigned on. The idea has been around for a long time. The foremost proponent in the Senate is Senator Cynthia Lummis, and she spoke this week at Bitcoin 2025, which I think is wrapping up today. I think it's a 3-day conference, but it's in Vegas. It hit huge numbers, 30,000, the largest ever. There are 5,000 companies represented. I mean, it's just incredibly large, compared to the SC conferences, it's more than double the attendance of those. So that's underway. She spoke, the vice president spoke at that, but I listened to hers, I listened to Saylor's, and she's leading the subcommittee for digital assets. And so there's a number of things that are happening, including stablecoin legislation, which is going through now. And it looks like the banks are going to be allowed to hold stablecoins and work with stablecoins. So that's going to be interesting. But on the Bitcoin Strategic Reserve, the initial tranche is already funded by moving a quantity of about 200,000 that had been seized in various fraud activities, moving those into the Treasury. So the Treasury Department has control of that. But to do more requires legislation. So she expects that legislation to pass. Senator Gillibrand is the Democratic lead in that subcommittee, and they work together very well for years now, she says. So it looks like the legislation will go through, and the strategy is revalue the gold certificates that the government holds really at the Federal Reserve, but they're carried on the books at $42. By pricing those up to market price above $3,000, that's a lot of instant money that could be used to purchase Bitcoin. And the plan would be to purchase up to 1 million in a 5-year period and to hold those for at least 20 years. And if you do, and you look at our power law projections, you'd be at 10 million per coin potentially by then. You could offset a significant portion of the federal debt by that time. So it's a strategic reserve capability that has monetary economic implications, but it also has security implications. So maybe I'll just mention briefly, some people may have heard of software, Jason Lowery's MIT thesis about the importance of Bitcoin from a security architecture aspect. And there's a new proposal out that is something called lock, which would allow you to essentially lock and make secure any file, any document. Doesn't have to reside directly in the Bitcoin blockchain at all. But the key itself would come from a specific transaction. And of course, you can have thousands of transactions in a single 10-minute block. So it's very scalable. And just the key would have to reside on the main blockchain, and it could use the key from the transaction. So that's an interesting way in which the security can be extended. I think I'll wrap this portion by mentioning that we do a CryptoSuper mining report twice a year. We do it in conjunction with the main supercomputing conferences. The reason we do that is Bitcoin is the largest decentralized supercomputer in the world. And I just did a look at how fast you can run the double SHA-256 hashing algorithm on a Blackwell and how fast you run it on the latest ASICs. The high-end ASICs now run up in the space of 500 to 800 terahashes.
That's amazing.
If you tried to run the same code on a Blackwell, it would be in the millions, the mega hashes. So we're talking, these ASICs are highly customized. They're in 5 nanometers going to 3 nanometers. And they're literally hundreds of thousands to 1 million times faster for that particular Bitcoin algorithm. So That will be mentioned on a report. And the size of the Bitcoin mining industry is now about 18 billion of annual economic value of production. And all the other coins have dropped away. Ethereum switched to proof of stake, so they're not relevant. The only other one that's slightly relevant is the Dogecoin, and it's producing about a billion per year. With that, I don't know if we want to talk about tariffs or something else.
Well, actually, what we want to talk about is the impact of quantum computing on Bitcoin,
Okay.
because there's been a big thread in preparation for such a day. So
Mhm.
that moves us towards the Q day. And at what point are we going to have a cryptographically relevant quantum computer? And there have been efforts there. So if you want to talk about that.
Sure. Based on what I read from the experts, is we're probably 5 years off from a Q day for Bitcoin wallets. But one has to distinguish between the hashing on the chain, which is Grover's algorithm, and attack on wallets, which is Shor's algorithm. And the Shor's algorithm attack can be on all of the banking system as well. And that's the one that's relevant. The hashing is not an issue for many decades. We don't have time to go into the reasons for that. But the Shor's algorithm, it might be 5 years away. And the estimates have been that you need around a million qubits, physical qubits, to get enough logical qubits. And there's a new paper out by someone at Google who had estimated 6 years ago that you would need 20 million. And he's now saying you can do it in a million. And it requires about, with the new design, he's got 3 different techniques and tricks, which are fairly recent, that were other authors had produced in the last 2 or 3 years that he's employed. And he needs about 200,000 qubits for computation, and he needs about 800,000 for storage. And he's got hot and cold storage in that. But that's a million. And with that, we're probably still 5 years away. There is a proposal already. And in fact, most of the risk is when you move, if it's just sitting on the chain, not doing anything with the wallets that have been around since 2012, you're not at risk. But when you move the money, that's when you would expose the keys and be subject to attack. And the proposals are to have quantum safe cryptography used for wallets. And those methods, there's several methods, there are 3 or 4 methods, either ones that have gone through all of the trials at the National Institute of Standards and Technology.
As I like to put it, where do you see quantum effects in nature? You see them everywhere. So depending on the backgrounds of the scientists and the engineers involved, you can go look after protons or electrons or positrons or atoms or ions or whole molecules or whatnot. So we see all those modalities. And there's also been the quantum annealing variety, which is the original quantum computer that D-Wave did many years ago now. And they're the only ones pursuing that. And while they're building a new variety as well on the side, they continue with the quantum annealing. So D-Wave announced a new version of their quantum supercomputer with 5,000 quantum annealing qubits, which are not the same as the million that this algorithm needs because they can't do the same things, but they are being used for interesting work. They've also talked about blockchain proof of quantum. It was a white paper that they announced.
Yeah. Well, I think the interesting thing is that there's just a paper out of USC, and they have a machine and access to D-Wave machines, so they have long familiarity with that.
Yeah, USC was one of the first universities to get a quantum
Right.
computer, and it was a joint work with NASA, USC, and D-Wave. And this was like 5-6 years ago.
Yeah, it was with an aerospace company, wasn't it?
Maybe Lockheed.
Yeah, I think it was Lockheed. And what the researchers at USC have come up with a new error correcting technique, and they claim that they can actually produce 1,300 logical qubits on this 5,000 qubit machine. And that's an extremely good ratio. That's a 4-to-1 reduction from physical to logical. Now, for comparison, there was a lot of noise a couple of months ago about Google's Willow chip. And that one had close to 100 physical qubits. And they were able to produce either 1, 2, or 3 logical qubits, with close to 100 physical. So that's a ratio of 27 or 28 to 1. So at least for the quantum annealing kind of architecture, there's a much better ratio of logical to physical qubits.
Yeah. So for those of you who don't track this market closely, there are breakthroughs relatively frequently, and the breakthroughs are real, but the number of breakthroughs needed to get to like a real quantum computer is tens, if not hundreds. So one has to recognize that these breakthroughs don't mean that we are so much closer to an actual quantum computer. So you got to really be careful how you interpret these results. The progress is real, but so is the hype and the expectation that comes with that. All right, fusion. Let's talk about fusion energy. There was some news in there.
A couple of pieces of news. One was at Dresden. It's a German government research institute located in Dresden, which was really one of the top research sites in the original Eastern Germany, when they were separate. They just have produced for the first time liquid carbon, and that's at 4,500 centigrade. They do it, very briefly using X-ray laser pulses, but it's relevant to fusion reactors that, because they'll run so hot that they may be able to, use some exotic materials such as liquid carbon in the future. And we are talking in the future. There's a lot of money going into fusion, just as there is in quantum computing. There are a lot of different design approaches. Most people are familiar with the sort of classical, magnetic confinement tokamak designs, but there are now designs that are hybrids between a linear accelerator or cyclotron, particle accelerators, and the confinement. And one such category is called stellarators, and they have complex magnetic field shapes, and it's very subtle problem to properly confine that plasma. You can't do it with the walls of the vessel. Those would melt. You have to do it with the magnetic field. And in the stellarator, you have some external fields as well as internal fields. And so just modeling those fields is a supercomputer problem. And so they're talking about some progress they were making in the design and modeling. It's both an AI and an HPC problem to do that. And this particular company is named Type 1 Energy, and they have a project that's funded or joint with the Tennessee Valley Authority. And they also use a different kind of fuel. Mostly you hear about deuterium and tritium as the fuels. And this is all part of the proton cycle that occurs in the sun, and in many stages ends up turning 4 protons into 1 helium nucleus. But another possible fuel source is helium-3, which is the alpha particle, but 1 neutron removed. And not surprisingly, that's something that's rare. You can create it. You need deuterium and tritium fusion to create it. It's hard to find, but there is also hope for lunar mining for that one. But it has certain advantages, but you also have to run even hotter. You need even higher temperatures to use that one. So again, having this good confinement and having good cooling with something, who knows, maybe liquid carbon.
So fusion is another area like quantum that is getting a lot of attention, a lot of money, a lot of promise, but also many, many breakthroughs needed to get to where it needs to go. So that's another thing to be careful about. All right, we covered quite a bit of material. Any other comments before we wrap this episode?
Sure. The age of the universe is less uncertain than it was. There was a fight over the age, and people were worried about it. But now there's some research out of the University of Chicago, and it uses the James Webb Telescope. And it says, don't worry, everyth's fine. We're good to within 3%.
All right. Well, on that reassuring comment, we can all...
Getting old is better than the alternative. How about that?
Yeah. It's the older age, too, so that's good.
That's right. All right. Well, safe travels, Adrian. Nice to see you all. And thank you all to our listeners for being here. Really appreciate it. And until next time, take care.
That's it for this episode of the Orion X Download Podcast. Every episode is posted to orionx.net and shared on social media. Use the comments section or tweet us with any questions or proposed topics of discussion. If you like the show, rate, review, and share it. The Orion X Download Podcast is a production of Orion X. Thank you for listening.